Hello everyone, welcome to this third episode where we continue our work with designing a Eurorack module using KiCad. So I have done some small touch-ups of the schematic diagram. I have moved around components and all the properties a little bit so it's more easy to see. I have added a couple of comments or text entries into the schematic diagram. This is the blue stuff you see here. And I decided to remove the flag for the trigger and instead use a wire because it makes it more easy to see. And but I still wanted to keep the net name. So what you see here is the net name of this net. And I talked earlier about the 18 nanofarad capacitor, and it's could be difficult to get hold of. So I have added a couple of extra unpopulated capacitors. So I'm using a feature here in KiCad that is called Do Not Populate to get this crossed over marking, as you can see. And I will also exclude it from the bill of material, but I will not exclude it from the board. All right, so I think that covers the latest changes I've done. So let's move on to the next step, and that is to assign footprints. In order to do that, we have a separate tool for that. So let's start that. And on the left side here, you have different libraries that we are going to use. We are going to take footprints from those footprint libraries. In the middle, we have our design, where all the unassigned components are marked with this yellow, light yellow color. And the ones that we have actually already selected the footprint, those are already, this field already filled in. And on the right side, we have, if we select a specific library, then we can choose from this list of different footprints. All right, so let's start with these two, the electrolytic capacitors. So I tend to use through-hole electrolytic capacitors in my design. I don't really see the benefit in using SMD types, since nothing that I'm doing is going in large volumes anyway. So I would, and I think that the SMD electrolytic capacitors are a little bit tricky to solder by hand, so I prefer to use the through-hole ones actually. All right, so let's see if we can find that. We choose capacitor through-hole type, and we have, it's this one, I think. Let's check. Yeah, this looks familiar. And if we look at the 3D model, it looks like the capacitor that I'm using. I try to reuse that for every design I do. So let's choose that one, and we do that by marking the fields that we want to set, and then we double click on this, and then you see that it shows up in this list. So the next one, in this case, we have a number of SMT 0805 components, and I will select all of them like this, and we will go to the capacitor SMD and choose this one, 0805 hand solder, because since I'm going to assemble these prototypes by hand, I prefer to use this one. The footprint looks like this, and the 3D model like this. So that looks like the correct component. We can save this so we don't lose it. And let's move on to the resistors. All of them are SMD 0805. So I will select all of them. And then we go here, resistor SMD 0805 hand solder. Okay, so that looks good. And then we have our potentiometers. We have a through-hole type. And here we have the type that we want is this one. Yeah, that looks familiar. That is the correct one. So we will choose that. We have our op amps, and those are SOIC. So we will find them. This one is the correct one. Yep, that looks familiar. Okay, so we have our Donkey Kong jacks left. And we're going to select the connector audio, this one. We don't have any 3D model for that. And we have the power connector. And this one is the connector IDC. And the one that we want is this one. Yeah, that's the correct one, the boxed header. All right, so the only thing we have left is the push button. And here I'm actually going to use, I'm going to use my own library for that. And it looks like this. Like so. So this is my own personal library. And that is one thing that over time you will probably need to add your own components. And in that case, it's a good idea to separate them from the rest of the KiCad installation and have a separate library that you are for those things that are using in your own designs. This is of course possible to download from I think I got it from some GitHub somewhere. I don't remember where, but I can investigate that and put the link in the description. All right, so now we have added footprints for all our components in our design. So we are happy with that, and we are going to save the design like so. Let's make a DRC check again. It's always good to do that now and then, just to check that we haven't broken anything. All right. Next step is to start on the layout. But before that, I would like to talk a little bit about the Eurorack form factor. We need to understand that in order to make the PCB. Before we start with the PCB layout, we need to decide on the PCB outline and build-up. The build-up of my modules are one single PCB with SMD components on the back and the interface components holding the front panel in place using the nuts for the pots, switches and jacks. The length of the board can be around 110 mm, but I normally limit it to 100 mm to save PCB cost. Some manufacturers offer good pricing on prototype boards that are no larger than 100 × 100 mm. The size of the panel is defined by the Eurorack industry standard. Module width is defined in HP, and that will set how big our PCB will be. The 909 snare module is 8 HP, which will of course give us a lot of room on the PCB. But 6 HP is probably enough for the Rimshot electronics. Okay, welcome back. So, I think it's time to start the actual PCB design now. And to do that, we launch the PCB editor. And I won't go through all the details how the PCB editor works, all the functions, but let's just take a very quick look at the right side of the program here. Here we have a pane with all the layers. So these are the 2 copper layers. And we also have silk screen and solder mask, and we have something that is called the edge cuts, where we define the board outline. And we also have something that is called user drawings. But the rest of the functionality, I will discuss them as we touch them in the design workflow here. So let's start by importing the design into PCB layout. And we do that by importing the netlist and the footprints. Everything seems to be okay. And here we have our design, all the components, all the footprints. And we also see that there are thin lines going back and forth between the components. And these are called rat nests. All right, let's move this a little bit to the side. Next step here is to add a board outline. And we do that by first selecting this layer that is called board outline or board parameter. we will draw a rectangle that is the board outline, and we will draw an outline that is 100 times 30 millimeter. So this is our board outline. What I would like to do now is to establish a reference point on this board. And I do that by marking out the middle point. So I will use that as a reference for all my measurements and dimensions. So let's start by doing that. And in that case, we have to move to this layer, user drawings. And for that, we have this. What we are going to do is marked halfway down, that is 50 millimeter, like this. And we will also mark the center point of 15 millimeter. Okay, so now we have a cross here, and this is our reference point for all the dimensions that we will add further on here. And there are a couple of things that we want to add. For example, we want to have 3 jacks here at the bottom, the 3 input, the velocity input, and the output. And they should be placed 10 millimeters from each side here. All right, so now we have defined the positions for the jacks in horizontally, and let's do the same thing vertically. And the correct dimension for that is 43 millimeter. So we will have our jacks here, here, and here. So now we need to define where the pots are going, and I think I will orient them around the center line here. So I will one up here and one here, and then we will have the button down here somewhere. The first one, and the second one will be 45 millimeter. Okay, so the button will be 22.5 millimeters from the center, like that, and aligned around the center line here. All right, so I think we have all our dimensions figured out now. We have the 2 pots, we have the button, and we have the Tonky jacks down here. So the next step is actually to start placing all the interface components and connectors and stuff like that onto the board. And I prefer to do this by just make a rough placement where the components are supposed to go. We will probably place this somewhere here, and we will rotate it. You can use the R key here as well for rotating, because we want to have pin 1, the minus 12 volt leads, we want to have them at the bottom. And we will, and the bulk capacitors, they need to be near the connector as well. And then we have the rest of the stuff, and we can put them to the side a little bit like this. Okay, so let's continue by placing the jacks. Here's the tricky part. These jacks are placed on the front side, which is actually the back side of the module. So what we want to do is to flip them over to the other side, because we want them to be facing upwards towards the front panel, of course. What we need to do is to decide where we want these jacks to go. In the front panel, I would like to have them in the order from left to right: trig input, velocity input, and to the right I want to have the output. And since what we see here is mirrored right now, we are looking from the component side, I need to flip these jacks over to the other side. I do that by using the F key. So here it's flipped, and you can see that the texts got mirrored, and that is because I'm looking at the component through the PCB right now. And I want to orient it something like this. Okay, this will be on the left side, this in the middle, and this on the right side. Let's see if we can, yeah, that looks okay. So they are placed on the correct side because we have the silk print here on top layer here. All right, let's add the power connector. Okay, so this looks okay. So we have the jacks at the bottom here on the top side. And we have the connectors and the capacitors on the component side. All right, let's take the switch next. Okay, so let's continue with the switch then. And this, I think this looks okay. So we have no collision on the component side. And on the top side is a little bit tight here. So you will probably have to solder these two before you solder that. But that is probably done last thing anyway. So that is okay. Let's place the pots. No, it doesn't seem to align properly. I think we have to increase, or sorry, decrease the grid size a bit here. Yeah, now it seems to be on grid. So now we have placed all the interface components. So let's save that and have a look in 3D Viewer. So the pots will go up here. And say we are very close to the top board edge here, but that is okay. It actually looks a little bit weird when everything is so close to the edges here, but remember that the Eurorack module is much higher or longer, or what you want to call that dimension. It will look nice when it's finished. Okay, so the next step is to approach this bunch of components here. And what we first need to do is to untangle this rat nest. And the way I do that is that I use this button to go to the schematic editor. And we are back in the schematic diagram. And then I will select components here, like so. And then I can go back to layout. And then you see that I have two components that are marked with a light red or pink color. So they are selected. And then I can press M to move these components. And then we can start to see where they belong. And both of them seems to be somewhere down here, which is not a surprise because we have the velocity input jack here. So they should be close to that. And what we can do is we will not place them yet. We will sort of have them in this area so we know where to find them. And then we'll work our way through the rest of the schematic diagram in this fashion. And so let's do that. Okay, now we can see that we have fixed the rat nest a little bit. We have clusters of components now with a lot of connections in between, but not so much all over the place like it were before. Okay, so with the first step of the floor planning done here, I think I have a rough idea how to do this. And I'm thinking of swapping places between U2 here with U3, and this part here is actually connected here. I would do that. In general, I want to have U1 down here, U3 here, and U2 some maybe between the pots here. These bandpass filter components are connected to the pots. All right, so I will burn through this and put my headphones on. Then we can have a look at the floor planning after that. Okay, we are finally getting something that starts to look like a layout. Let's have a look in 3D view. You can see here that it's actually quite a lot of space here, so I'm not so concerned about the routing. I think the placement is good. There is some space between the components for the silk print, and it looks a little bit messy now, but we will tidy that up afterwards. And actually I think this is a 6 HP module, and I actually think that it would be possible to shrink it down to 4 HP if we removed the key, the cherry key here, and also rearrange the jacks a little bit. Let's close that. So the next step is to start routing the board, but that is something that we will do in the next episode. So until then, thank you for watching, and I see you soon again. Goodbye.